All right, this is video number 3 of 6. This one, I think you'll like these. These are pretty straightforward. Radicals on both sides. Again, what do we need to do to get rid of a radical? Well, first thing in this step, it said to isolate the radical, but here it is on both sides. It's kind of hard to isolate it. There's one on each side, but it sets up perfectly for us to just go ahead and eliminate those radicals by doing the same exact thing to both sides. And what we're going to do to both sides is we're going to square both sides. So if I square both sides, I end up getting out whatever's underneath each radical. 2x plus 5 equals x plus 7. And now I just have a linear function that I need to solve. At the end of this, I do need to check to make sure that I did find the real solution, which checks inside of my original. I'm going to move both x's to one side. And then I'm going to move the 5 to the right-hand side. I've isolated x on one side all by itself, and I get that x equals 2. We're going to do the check for these because some of these are going to have extraneous answers. In this case, we don't have an extraneous answer because when I go to plug this in, I get 2 times 2, plugging in for x, plus 5 is equal to 2 plus 7, the square root of that. So I get the square root of 9 equals the square root of 9. And that's a check. What you're going to be looking for when you check these is that you know that you cannot have a negative underneath the radical. You want to watch out for that. Then you want to watch out that you don't have a square root that's going to be equal to a negative number. And I have an example of those both coming up. This is a straightforward example of how you solve something that has radicals on both sides.